let's just talk. So I'm recording. So you can write this bit. We're going to make some notes on this first sheet. So it says, I want you to clearly communicate your algebra exclusion by showing equivalence transformations. I'll explain what that means in a sec. Your ATL is organisation and communication. This is what we're working on today. Okay? What we think we are communicating is not necessarily what is appearing on the page, like that guy that did his test. All right? Like when you write something, have you been given the advice if you've written a story or something in English INS, what you should do is get someone else to read it? Because if you read your own work, you're actually not really reading. You're remembering what you intended to put down, and you can't spot your own mistakes, right? That I do that all the time in report writing. You know, I go, yeah, I've checked my work 3 times. Someone else reads it and go, oh, you spelt that wrong. What? Because you don't read what you've actually written. You read what you thought you wrote. An equivalence transformation is another statement. Oh, I should check that. Sorry, that's bad. Always check your work. See? Based on the original with a chain, but it's still true. Remember I said with that guy's work? Too many lies, things that are not true anymore. So, I'm going to say to you, Q plus 4 is 19. That means a number plus 4 is 19. I'm sure you've all done that in your head already, right? The answer is Q equals 15. We know that. But I'm going to tell you the equivalence transformation and which direction are we working. Down. You'll notice how I've gridded my page, right? So I'm going to write an equivalent transformation, which I'm going to think about my function machines. And I'm going to say, well, if Q plus 4 equals 19, then Q plus 4 subtract 4 equals 19. Subtract 4. Sorry, not 14. Subtract 4. Now, does that make sense?
Yeah.
Right? You might be going, I don't know why you've done it, but it is true, right? If I subtract 4 from both sides, is this still true? Is my equal sign true?
Yeah.
Yes, it is. Now, just to make you clear, if I write Q plus 4 minus 4 equals 19 without the minus 4 on the other side, is that true? That would be a no. Okay? So I'm going to say minus 4, and when, do you notice how I did it before? I put it above. Well, I'm improving on that, so maybe that's not the best way at the moment. So I'm actually going to write the proper equivalence statement. Have you all written that down for yourself? Okay? What I'm then going to do is I am going to simplify those equivalence statements, which is, well, if Q plus 4 minus 4, that's just the same thing as Q. Because if I add 4 to Q and then subtract 4 from that answer, I'm just back at Q, right? So that is equivalent to what's above it. What's equivalent to 19 minus 4? 15. And now look, I'm at a stage of going, oh, well, now I know what Q is. Yeah? So that's me writing equivalence transformations. I have changed the statement. What was the change that I put in? Well, the plus 4 wasn't a change, that was there before. Just the minus 4. The minus 4 is the change. Why did I choose to write minus 4? Do you want to answer that, or have you got something different?
Because you added 4, so then you're going to take away the 4 that you added to cancel out the...
Exactly. So I decided now I can do anything I like as long as it's correct. But the most efficient thing to do is subtract 4 because that gets rid of the plus 4. What's that called, by the way? Doing an inverse. Good, an inverse operation. Negative 4, subtracting 4 is the inverse of adding 4. Okay? Should we have a look at this one then? What would be the equivalence transformation I'm going to write?
6.
Well, it's 6 times C is equal to 48. What would you like to do to change it?
Divided by 6.
Okay, not just 48 divided by 6, but both sides. The equivalent statement, that's the initial statement. What change am I going to make? Well, I'm going to divide that side by 6 because that leaves me with
C.
1c. 6 c's divided by 6 is 1c. But what do I have to do to the other side to keep it equivalent? Also have to divide by 6, and I'm left with 8. Yeah. Again, why did I do divide by 6? Because dividing by 6, Justin. But why did I choose to divide by 6? Kenneth?
Like 6. So.
Well, what is 6c? It is a... Dividing by 6 is the inverse of multiplying by 6. Yeah? So in this one, subtract 4 is the inverse of plus 4. In this case, dividing by 6 is the inverse of timesing by 6. So it gets rid of it. Okay? But can you see how we're looking? Nice and neat, clearly communicated. Have you written all this down, John? Kind of facing the wrong way as well. Might be easier to turn around a bit. Okay, we're only dealing with one step equations, but that's fine. It's all I think we need to do at the moment. What about this one? Oh, we're still writing. Right, this one then. This is z gets divided by 7 and equals 5. So we're thinking I need to do the inverse of dividing by 7 is fraction. A division is a fraction.
Exactly.
But in this case, we're thinking that a fraction is a division in this case. I'll do this. I remember what it's do there. Alright, we've got z divided by 7 equals 5. What's the inverse operation I'm going to do? So we're going to do, if it's divide by 7, we're going to times by 7. What do I have to do to keep it equivalent and true, Jess? That's important. We're fully focused at all time. You don't really know where we are, do you? Riley? Times the 5 by the 7. Now I've written it, I've left a bit of space because I knew it was happening. So as you get. Now that leaves me with, what is 7 times z divided by 7? What's 7 times z divided by 7? I'm working on the left-hand side, Giovanni. You're not doing what we're doing. We're just messing around with your Bible. What is that, Giovanni? Can you tell me? What is 7 times z divided by 7 or c divided by 7? So same thing to you then. This is why it's important that you remain focused, not doing other things. Writing it down is not the end of everything, yeah? Thinking. Abby. What is 7 times z divided by 7? Just z. I'm left with just the z. Sorry, if I say z, it's because I'm so used to it. I try and remember. So this is the result, the simplification on that side. What's the simplification on this side? Same hands going on. Jordan, what's the simplification on this side? 35. Okay, and we just end up with z equals 35. Okay? What is the focus of the lesson? Communication. Do you see how I clearly communicate this? We're trying to get away from, oh, I don't know how to do it because I just know what the answer is. You knew the answer to all of those. I can suspect, though, most of you would, not most of you, some of you would have looked at this one and not, it doesn't work quite in your head. Yeah? You're thinking, you know, I need to do, well, I know what's going on, I find it hard to explain what's going on. You're looking for the wrong thing, the opposite way around. So be very good to write down your inverse operations. Okay, so I picked a few. Which ones have we already done? A, E, G. Okay, so I'm not going to worry about this bit, explaining words. Just need to solve it, but showing all your working, okay, in your maths book, not on the paper. Okay, so we've done those ones, you don't need to do them again. You can do the others and rattle through, right? This one, which are the same solutions where you basically got to do them all and then figure out what, so you're just doing them anyway. Awesome. So you've